So, the next part. In addition to the probabilities areas for the 68, 95, 99 rule, you can also find the area using a graphing calculator. For this exercise, I'm going to use the tables because I'm not sure everybody has a graphing calculator, so I'll just use the tables. So, cross that out. I'm going to say using a table. The table gives you, and same thing, the table or calculator, doesn't matter, calculator or table, will give you the area always to the right, or to the left, sorry, always to the left, okay? You can use a graphing calculator for this, but I'm just going to show you how to use the tables, because it's just as easy. So, first thing, sketch a graph of the standard normal curve, shade in the area of interest, and use the table or calculator, so we're going to use the table to find the area. Okay? So we have determined each area under the standard normal curve to the left of 1.57, to the left of 1.57. So what I would do is I would have my curve. Okay. I would look at my table. Oh, this one doesn't actually show it. This one shows it pretty well. And the mean is always assumed at 0. At 0. And you have two tables. You have one that has negative values, and you have one that has positive values. These are for the Z values. So if I look at the question again, it says to the left of 1.57. That's a positive value. So that means I'm going to have to be looking at my positive Z table. And the positive Z table, I'm going to have to look at 1.57. So here is 1.5. And then I look up at the top to get me my second decimal place, 7. So I go down where it matches up with the 1.5. 1.50, 1, 2, 3, 4, 5, 6, 7. So 0.9418. 0.9418. 0.9418. Okay? 0.9418. And how that would kind of look is, for my normal distribution curve, I would have 0 as the mean, and I would go up to 1.57. So there's 0. That would be 2. So there is 1.57. And what it gives me is the area to the left. So it's going to give me all the area to the left of the entire curve, underneath the entire curve. And that area represents 0.9418, or we could write that as 94.18% of all my data. So the Z table gives you the decimal. If you needed to convert it to a percent, you would just convert it to a percent. All right, the next one. To the right, oh, there's a different one now. To the right of negative 2.45. So again, I have my curve. Oops. Let's draw that a bit better. My curve here. That's even worse. Oh well. And here is my 0. Negative 2.47 is going to be over here somewhere. And we want the area to the right this time. To the right. So we're going to have to do something a little bit different. Because the tables always give you the area to the left, this time we're looking at negative values, we want negative 2.47. So I look for negative 2.4 right there. And then I go over 0, 1, 2, 3, 4, 5, 6, 7, matched up with the 7 at the top. And I get 0.0068. But that is the area to the right. Or sorry, that is the area to the left of the curve. So that would be like the area over here, but I don't want that area, I want this area. You have to know for this one that the total area underneath the entire curve is the total probability, which is 1. Which is 1. So the total probability is equal to 1. We have to subtract off the area that's over here, which it gives us, which was 0.0068. So 1 minus 0.0068. 1 minus 0.0068, which is equal to 0.9932. So that means the area here is 0.9932, or 99.32%. Okay? So when you're dealing with to the right, you're going to have to take the total, which is 1, and subtract off the area for which you found in your Z tables. Okay? Start off with 1, subtract off the area that you found on the Z tables because we're looking to the right. Next one, between. Okay, now this is even different. So here's my curve, my 0, and I want between -1 and +1. -1 and +1. I want just the area between here. The way to find that, again, the Z tables always give you the area to the right, So if I take the area to the right of 1, I'm going to get all the area there. If I take the area to the right, to the left. If you take the area to the left of 1, you get all the area over there. If you could take the area to the left of -1, you get all the area to the left of -1. I want just the area in between. So what I have to do is I have to take the top one, all that area, subtract off the bottom area, and then I'll be left with just what's in between. So take the top minus the bottom. Top minus bottom. Okay, but we still have to use our Z tables to figure this out. So, first thing I look at is 1, the area for 1, +1. Oh, so I'm looking at my positive table. 1, now I'm not going to be going over any because I just want 1.0, which is 0.8413. Whoops. So I get 0.8143 minus the bottom area, which is -1. So I go to -1 and just do the first one over, which is 0.1587. 0.1587. I subtract the 2, so I get 0.8143 minus 0.1587. I get an area of 0.6556. 6556, which is equal to 65.56%. Okay, so 65.56% of the data lies between -1 and +1. Okay, and that's just using the Z tables and subtracting off the top minus the bottom. Same thing, so I have between -1.3 and 2.1. So again, I take the top minus the bottom, and the top value is 2.1, so I'm going to have to look at my positive Z table. 2.1, and it's just 2.1, so it's going to be 0.9821. So 0.9821. The bottom is -1.3. -1.3, and again, it's just the first one, I'm not going over any, is 0.0968. 0.0968. I subtract the 2, so I get 0.9821 minus 0.0968, and I get an area of 0.8853. So I get 0.8853. I didn't sketch this one this time because I'm just dealing with just the areas. So 88.53% of the data would lay between -1.3 and 2.1. Okay, -1 in the same method of right above there. Same thing. Last one, between 1.5 and 2.5, or 2.5. So top minus bottom again. So the top is 2.5. Look at my positive Z table. So I get 2.5 is 0.9938. So 0.9938. Subtract off the 1.5. That's a positive value again. So I go 1.5, 0.9332. Okay, and that one is going to be equal to 9938 minus 9932. Whoops. 0.9938 minus 0.9332 is 0.0606. So 0.0606, or that's equal to 6.06%. Okay, so it's a good idea to think in terms of your decimals and your percents. and your percents. Like right here, it says what percent of the standard normal population is between negative 1.5 and 2.5. We've done those. And that's just converting it to a percent afterwards. If it asks for, what are these ones? These ones ask for determine the area under the standard normal curve. So the area is the first number. Area is the first number. So the 0.9418, the 0.99, the 0.66, this one here, that's the area underneath the curve. The percent, if it asks for a percent, you need to convert it to a percent. So this question is exactly the same as the ones that we just did above. So we got negative 1.5. So we're looking on a negative table. Negative 1.5 is 0.0668. Oh, we just did that one, right? So the one above, the percent is going to be 6.06%. So if it asks for the percent, convert the area to a decimal. Convert the area to a decimal. And remember that convert the area to a percent. And remember that the area underneath the curve, the total area is always equal to 1, because the total percent is 1. 100%, which is equal to 1. All right. But what if we aren't given the data in terms of the z-score? Right? What if we aren't given that? We can convert any set into z-scores by using this formula here. Z equals x minus mu over sigma. X is your given value, mu is your mean, and sigma is your standard deviation to get your z-score. Why is that important? Because once you have your z-score, you can just look on the tables, right? Once I have my z-score, I just look at my value of my z-score and I look over here to figure out what percent or what area I'm dealing with, right?